In this problem, Tim swims 2 laps for every 3 laps that Maggie swims. If Maggie swims 60 laps, how many laps did Tim swim? And we're going to support our solution with the ratio table. So that was my first read. So now I'm going to go ahead and I'm going to read it a second time, and I'm going to go ahead and mark up some of the things that I see in the problem. It says Tim swims 2 laps for every 3 laps. Right there with that for every, I see a ratio and I see a comparison of 2 numbers and a period. So this is my starting ratio. And it says if Maggie swims 60 laps, how many laps does Tim swim? So we're looking at the laps that Tim swims. That's our third read of trying to figure out what we need to do with our problem. We're going to use a ratio table. So I'm going to set up my ratio table. I'm going to set it up as Maggie to Tim. And it says Tim swims 2 laps for every 3 laps that Maggie swims. So Tim swims 2 laps for every 3 that Maggie swims. And if Maggie swims 60 laps, so we'll put the 60 up here, how many does Tim swim? That's our target down here, is to find out how many Tim swims. So I'm going to go ahead and I'm going to double. If I double this, I do times 2. I get 6 laps for Maggie. If I double this, I get times 2. I get 4 laps. Now some of you might see we can go right here as times 10, and we could do times 10 so that Tim would swim 40 laps. And remember, there's more than one strategy to do here. If you didn't want to double, you could have maybe times by 10 first and then times by 2. So there's a lot of different ways that you could have solved this, but we're showing our solution within the ratio table and we get an answer of 40 laps. Tim swims 2 laps for every 3 laps that Maggie swims. If they swim 15 laps total, how many laps did each person swim? And this time we're supporting our solution with a tape diagram. So again, that was my first read. My second read is I'm going to go ahead and find my starting ratio. 2 laps for every 3 laps. Here's my comparison of 2 numbers within a sentence. And we know that they swam 15 laps total, and I'm going to circle total because that's important. And how many laps did each person swim? Okay, so we're going to start out again with Maggie and Tim. Tim swims 2 laps. So we'll put a T here for Tim. Maggie swims 3. So it's similar to last problem. In fact, problems 1 through 5, I believe, all deal with the same starting ratio of 2 to 3. And they want 15 laps total. So I see here I've got 2 laps by Tim. I've got 3 laps by Maggie. So they swam 5 total laps. So I'm going to put T-O-T-O-A-L here for total. Total of 5 laps. Now I have one of 2 ways to do this. I can go ahead and finish my ratio and double it and do 3 here. So now I see that they have 10 laps total, 4 for Tim and 6 for Maggie. And I can do it again and another 3. And so now I see there's 2, 4, 6 for Tim and 3, 6, 9, and there's 15 laps total. So that means that Tim swam 6 laps and Maggie swam 9 laps. Or you could have set it up if you had your 2 to 3 ratio and you wanted to do it a little bit faster. This is Tim and this is Maggie again. 5 laps total here. You know that we have to get to equals 15 laps. So I say what 5 times what number gets 15? Well, that's 3. That means I have to do 3 times 3 and 2 times 3 to maintain that equivalent ratio. So again, it would be 6 and then 9. And when I add them together, I get 15. So I still come up with the same answer. This is still working with the same scenario of Tim and Maggie. And we know that our starting ratio was Tim swims 2 laps for every 3 laps that Maggie swims. So here I see the 3 for Maggie. So I know 2 is going to go up here. Here is their starting point. So if Tim swims 0, Maggie swims 0. So they're just basically at the origin, they're stopped. So now I'm going to go ahead and work my table to figure out the rest of this scenario. So I see that 2 times 2 makes 4. So I would do the same thing on the bottom to maintain equivalence. So that would be 6. So for every 4 that Tim swims, Maggie swims 6. Still maintaining equivalent ratio because I did the same thing to top and bottom. I'm not exactly sure what's going to go here. I'm going to assume it's a 6. So we'll go 2 plus 4 makes 6. So I can add these together. So I add together 2 plus 4, the columns. That makes 6. And I add together 3 plus 6 to get 9. Now, to get 8, I can go back and I can double my 4, so that's times 2, and I can double my 6, which makes 12, still maintaining ratio because I'm doing the same thing top and bottom. To make 15, I can do one of two things. I can add together 3 and 12. I could add together 6 and 9. I could do 3 times 5, whichever you wanted to do. I'm going to go ahead and do 12 plus 3. Makes 15, so I added together this column and this column, which means I have to come up to the same top numbers here, and I have to do 2 plus 8, because all I'm doing is adding equivalent ratios together to get 10. So now I'm going to make 20, so I'm going to go ahead and times 2 here. I'm going to times 2 here, which makes 30. And then if I needed to, I could fill in, but hopefully you recognize that this is going to be times 100. And then I'm going to go ahead and times by 100 here to get to 3,000. And these would all make equivalent ratios. Now when I go to graph it, when I'm looking at this, I'm not dealing with constant speed because I'm not dealing with time, I'm just dealing with laps. So this is going to be our X and this is going to be our Y. So Tim is going to be here, our label for Tim, and for our Y is going to be Maggie. And we're going to go ahead and graph a couple of points. So I see the origin here is at 0, 0. And then I'm going to skip a couple and I'm going to look at Tim's and he goes 0, 2, 4, 6, 8. So I'll do 0, then we'll do 2, 4, 6, and 8. And then up here I have 0, 3, 6, 9, 12. I see a pattern there. So I'll do 3, 6, 9, and 12. And I'm only skipping some because it's a little difficult to write with this. And I graph 0, 0. I'm going to graph 2, 3. I'm going to graph 4, 6. I'm going to graph 6, 9. And I can graph 8, 12 here. And I can see that they make a straight line. So I know that I have a ratio table because I've maintained equivalence, and the straight line proves that I am doing it correctly. So in the next question it says, do the ordered pairs appear to be random or do they seem to follow a pattern? Well, they follow a pattern. They're equivalent ratios because they form a straight line. And that's what you would want to look for from a table to the graph to see if that you have equivalent ratios. The soccer team won 4 times as many games as they lost. And it says, think here, what is this ratio? If they played 30 games, how many did they lose? And we're going to use a tape diagram to solve. So I'm going back in for my second read, and I see that they won 4 times as many as they lost. I know that means something. I'm going to figure that out in just a minute. There's my period, plus here's my little hint. If they played 30 games, how many did they lose? So that was my reading for purpose and kind of marking up my text. So I have to think to myself, what does 4 times as many mean? So if you think of a number like 8, well, 8 is 4 times as many as 2. So if I go ahead and simplify that, I can see that that's a 1 to 4 ratio. So if I have 1 loss, I'm going to have 4 wins because that's 4 times as many. And it says here that they played 30 games total. So I look here and I say, okay, well, I got to find a total. If I have 1 game lost and 4 games won, that means I played 5 games altogether. So I'm going to simplify this because this is going to be a lot of repetition. You can do that to find 30 games total, but I do know that 5 times 6, that's my missing value there, makes 30 games total. So I have to come up here and I have to do times 6 because I have to maintain equivalence. So 4 times 6 is 24. And I have to do times 6 again. 1 times 6 is 6. If I add those together, I get 30. So my question says, how many times did they lose? They lost 6 times. And that would be my final answer. Identify all equivalent ratios for 2 to 50. So I'm going to go ahead, since I have all these different ratios I have to find out, and I'm going to go and put it in a ratio table to find all equivalent ratios. So I have 2 and I have 50 in that order. I'm going to first go ahead and find a unit rate, which is 1 to 25. And I see here's 1 to 25, so this is one that applies. From here, I'm going to see if I can get to 25 to 1. So that would mean I'd have to multiply this by 25. Well, if I multiply the bottom by 25, that doesn't work out. So this is not an equivalent ratio. I already have 2 to 50, so it can't be 2 to 3. There's no way for me to make that. This one is not an equivalent ratio. So let's see if I can make 4 to 100. If I put 4 in my ratio table, I see that 1 times 4 is 4. 25 times 4, if you think money, quarters, 4 quarters makes $1. This is an equivalent ratio. And already I see 6. Here's 4 plus 2, so we'll do a 4 plus 2 on my next one to get 6 on the top. Hopefully it works. 100 plus 50 is 150. So this is an equivalent ratio, and I just use my ratio table strategies to check. A jet travels 510 miles in 5 hours. At this rate, how far could the jet fly in 13 hours? What is the rate of speed of the jet? So there's 510 miles in 5 hours. I see two numbers being compared followed by the period, so I know this is going to be my starting ratio. I want to know at this rate how far he can fly in 13 hours and what is the rate of speed. I know I'm dealing with speed because I have distance and I have time, which means that I'm going to be looking at finding my per hour rate. So I'm going to go ahead and set up my ratio table. And since I'm comparing miles and I'm comparing hours, I know there's 510 miles in 5 hours. And my target is 13 hours. And I know 5 doesn't go into 13, so I'm going to kind of work my way up into 13 on the bottom. So I'll put it out here. We may use it, we may not. And I'm going to go ahead and find my rate of speed first. And I know that means I need to find out in 1 hour. So I'm going to divide by 5. And I'm going to divide by 5. And when I do 510 divided by 5, and I can do that on my calculator if I want, I get 102 miles in 1 hour. So my rate of speed is 102 miles per hour. So I've already answered one of the questions. Now I need to find 13. Now let's say you weren't working with a calculator. I'm going to show you a way that you can do this without having to use a calculator. I'm going to go ahead and double this. So this becomes 2 hours. And I'm going to double this, which becomes 204 miles. So there's 204 miles in 2 hours. I'm going to add together the 1 and the 2. So I'm going to get 3. So that means I need to add together 204 and 102 and get 306 miles in 3 hours. Now I see that I'm 10 away from 13. So I'm going to come back here and I'm going to multiply by 10. And I'm going to multiply 102 by 10. And I'm not doing any of this on my calculator because I know how to do this in my head. So this becomes 1,020 and this becomes 10. So now all I need to do is add together 10 plus 3 because these are all equivalent ratios. That makes 13. I add together 1,020 plus 306, which becomes 6, and then 2, 3, so 1,326 miles in 13 hours. And that's answering my other question of how far could the jet fly in 13 hours. He can fly 1,326 miles.